Okay, hello and welcome all. Thank you very much for joining us for what I know is going to be a very insightful discussion. Now, in today's embedded design landscape, the decision to use an FPGA can be pivotal, yet not always obvious. While many applications are well served by off-the-shelf microcontrollers or fixed-function devices, others demand greater flexibility, performance, and integration than standard components can offer. So to explore where programmable logic fits into modern system design, we've brought together a panel of experts from Microchip and DigiKey to share their perspectives. So let me introduce our speakers today. First up, we have Martin Kellermann, who is the marketing manager for FPGAs at Microchip Technology. Now, in this role, Martin works with the European sales and field application team to position the strengths of Microchip FPGAs and SoCs to clients. He is a seasoned FPGA and SoC professional with a track record of successful customer and project engagements in the industrial, automotive, and data center domains. Martin possesses a strong background in high-speed serial data transmission, signal integrity, and hardware debugging, which has helped numerous customers finish their designs successfully. He's also taught courses covering industrial applications and hardware concepts, and he holds a diploma on electrical engineering from the Landshut University of Applied Sciences. So, pleasure to have you, Martin. Thank you very much for joining us.
Thank you, Paige.
We also have YC Wang, Director of Global Academic Program at DigiKey. Now, YC brings about the convergence of industry, maker, and academia through the DigiKey program. His passion is to build the next generation of electrical and computer engineering movers and shakers in the industry. He believes that hands-on hardware skills are something that all engineers need to acquire at a very early stage of education. He brings with him over a decade of experience in semiconductor companies, especially the FPGA industry, and has deep connections to academia across the globe. So welcome, YC. Pleasure to have you as well. And last but not least, we have Josh Booth, who is a product marketer at Microchip Technology. Josh is a microcontroller expert with a specialization on the PIC16 architecture. As a product marketer at Microchip, he uses his technical background to guide practical product decisions and clear communication. He enjoys working across teams to ensure solutions address real-world needs in embedded systems. So welcome very much, Josh, and let's kick things off. So Martin, why don't you start by telling us why would an engineer want an FPGA in their design?
Yep, can do that, Paige. So honestly speaking, probably a lot of engineers don't really want to use an FPGA because there are the known truths about FPGAs: complicated, expensive, can't really use them, they're unreliable, all things that are typically taught at uni. And very often those prejudices are at least matching enough that an FPGA is not really required. On the other side, also, when you have something which already works, which is good enough, which already covers something that you do, then a microcontroller can be good enough. But for those situations where you don't really have the existing finished microcontroller, if some peripherals are missing, if the performance is not high enough, that's typically when the situation with the FPGA comes in and its beauty really blossoms. The flexibility to build your design, your chip, to what you really need in the combination of what you really need. That's typically when the engineers then come along and say, well, actually, yes, the FPGA is the tool of choice that I want to use in my application. So typically, really, when you need something that doesn't exist on the market, when you need to have a straightforward, in inverted commas, an easy way into building your own chip.
Brilliant. So what kind of design flexibility might be benefited from programmable logic? Josh, perhaps you can provide some insight for us.
Yeah, I'd love to. Kind of as Martin just mentioned, that FPGAs are a great solution when you need a very specific functionality in your design, compared to something like buying an off-the-shelf microcontroller. And with that custom design on the FPGA comes a ton of flexibility, often at the cost of initial development. It takes a while to spool up a solution on an FPGA compared to a microcontroller. So you get a lot of extra design flexibility when you use this, pre-built, this own built solution that isn't confined to just having to operate on a single core and then their peripherals. These FPGAs can scale from very small devices to very large devices, depending on what you need them to do. At Microchip, one of our latest innovations has been a tiny FPGA that operates alongside a microcontroller called a configurable logic block. It's a very, very small FPGA, about 30 lookup tables that is on the same silicon die. And then you get the best of both worlds, where you have your microcontroller doing most of your functionality, but the parts that need abstracted or accelerated to an FPGA, you have that architecture sitting right next to the microcontroller, and they can communicate. So if you need, let's say you have a microcontroller that's doing some communication in an industrial system, and you just need to read a quadrature encoder, something that's traditionally very CPU heavy, you can offload that functionality just onto the CLB. So in that way, you have this microcontroller and FPGA architecture working in tandem for the cost of a single entry-level chip. The CLB is on our newest microcontroller, the PIC16F13145. So by putting these two together, you get a lot of ways to maximize your functionality per dollar. You get a very, very tightly coupled design. The CLB gets traditional PIC16 advantages, such as native 5 volts. You have the microcontroller there that has integrated analog that can feed inputs into the CLB. You get very, very low power consumption that's known with the PIC16 family. And you really get to maximize the efficiency in your design. So you get a lot more flexibility when you look at these solutions that come with, going down the dedicated FPGA route, where you're going to build it all from scratch, or look at new options in the market if you only need a little bit of programmable logic to go alongside your current embedded solution if you're using a microcontroller. Now, when it comes to scaling your design, it depends on what you're looking for. Like I said, we have this low-end option for, if you only need to do 20 to 30 lookup tables. But then I know Microchip has a lot of other options and SoC components if you're going to need to go to scale larger than that. If you need 20, 30 IO, the CLB only has 8. And so these trade-offs are very critical when figuring out what flexibility you want to put into your design.
Yeah, definitely. And YC, what are your thoughts on what Josh has just described there? Any insights you'd like to share?
I think the ability and the feature of having the CLB integrated into a PIC16 is quite incredible. It simplifies the bill of material tremendously for the end customer, and also the complexity of the PCB design. With the traditional standalone FPGA and microcontroller configuration on a board, you have to worry about multiple devices, multiple decoupling capacitors, multiple voltage power supply considerations. With this one device, you simplify the design work tremendously, saving a lot of footprint and potentially cost of manufacturing. So this is actually an incredible product from the way I see it.
Fantastic. And Martin, carry on.
Yeah, maybe just adding also on that, as Josh mentioned, the 5 volts. So 5 volts in the larger FPGA sizes is typically something which is already considered high power by now. So trying to apply 5 volts onto an FPGA, you can do it, but it will only work for a very, very, very limited time, and then magic smoke will come out. So in those combinations where you would really need to have 5 volts in something larger, more complexity, also the combination of those two is actually pretty nice. You have the 5 volt and its programmability on the CLBs, but then on the other side, the more performant, the larger, and also very scalable approaches with larger FPGAs, larger FPGA-based SoCs that range up to 500,000 logic elements.
Fantastic. And Martin, do you want to chat about some of the applications as well? I know sort of industrial and medical areas are quite key.
Yeah, I can do. So when you look at industrial and medical, those applications are typically something where you have something very specific. You have specific interfaces. You have a specific interface on the one side of, for example, to the instrument for endoscopy, and on the other side you have then some communication channel into an overall system. And very often it's something where you also need to do some very specific processing, especially also geared towards something with very low latency. Imagine you're an endoscope and you're going into the human body. You really want to have virtually no latency at all. Because if you move and you see it too late, you're going to move too far. And that's an important thing where the latency is really also one of the very big benefits of the FPGAs. But image processing, typically something significantly beyond the small CLBs that Josh mentioned. It's more the realm of the larger FPGAs. Also, think about industrial. If you look there, industrial also is very often a combination of something standard and something very specific to that one application. Be it some PLC, which has the proprietary backplane interface, and then having to interface with a standard industrial network interface. So again, this combination, flexibility together with the standards, is something where the FPGAs are really, really playing well. And in both application areas, both industrial areas, one very big topic is paperwork and the cost of paperwork. Medical certification, safety certifications, getting all the stamps onto the paper until you're allowed to sell it, that's a huge investment. And if you're in that situation, you really want to keep your investment. You don't want to recertify because you simply had to change one of the devices. And that's where also the microchip longevity comes in very, very handy. Talking about 20 years longevity, availability in the market as of now, that's something really, really powerful and very valuable. It really protects your back, it protects the invested time, and also protects you from doing recertifications.
So given all that you've said so far then, Josh, I'll come back to you. How can a user get started?
Yeah, so there are a ton of different avenues depending on what you're looking to do with your design. I know Microchip has the Libero software suite if you're looking to get into the large FPGA side. But for me, who has a microcontroller background, I found it very daunting to have to learn a whole new tool suite to even to get started. I prefer the tool that we've launched with the CLB. It's called the CLB Synthesizer. It's a completely online drag and drop interface that will give you your CLB configuration. And there's a line of code that executes on your microcontroller that can load this configuration. The URL is logic.microchip.com/CLB for getting started. It's also integrated into our MPLab tool suite and Microchip Code Configurator, our graphical configuration tool, if you've ever used any of our Microchip microcontroller products. I found it's kind of the easiest way to get started with programmable logic. I've tried some CPLD tool chains. I've tried some other FPGA ones, and you can really do an end-to-end design in the CLB synthesizer in under 5 minutes, getting something running. So it's great if you're doing an intro to programmable logic. If you just want to scaffold up a design, it supports all your design primitives as well as some Verilog, and it now has timing simulation, so you can see how your design is going to respond to the things you're building up. It also has a nice help center to give us immediate feedback if you're running into issues. And it has a large library of resources online. If you want to see code examples or demos that use the CLB to get some ideas, just go to discover.microchip.com and search CLB, and there'll be over a dozen different ways to use and different examples.
Fantastic. And YC, I know you've had a little play around with this tool. What are your thoughts?
I think it's an excellent tool. I taught FPGA to returning professionals a few years ago. And I have to say that compared to other industry grade FPGA tools, the CLB synthesizer is extremely easy to get started with. Since it's hosted and online and can be run on a web browser, you really do not need to download a massive, bulky FPGA design tool and worry about licensing issues to get started. You can jump right in, and it's graphical. There's a benefit to having a graphical interface with drag and drop blocks for people who may not be familiar with FPGA design. And so that is extremely powerful in that sense. It allows, as Josh puts it, a microcontroller programmer to get quickly into designing the necessary logic to support the microcontroller design. For those who are a little bit more advanced, the intermediate files generated by the CLB synthesizer can be viewed in Verilog, and it will show your design in Verilog, which I assume can be copied and pasted into more professional tools. So in general, I think it is an excellent tool to get started. And the fact that it's free and it's very easy to use, if I were still teaching my FPGA course, I'll probably introduce that tool as the first tool for our students to get started with.
Excellent. That's good to hear. Martin, any extra thoughts to add about, how users can get started?
Yep. So thinking back on how I started with FPGAs, my initial installation was still fitting on a CD at that time. So it's a couple of days since I did that. But also in my case, it was really doing a bit of the graphical design when schematic capture was still something on the larger FPGAs at that time, which was kind of okay. And trying to understand that way into the hardware is actually a pretty good way. Theoretically, in the tool that we have today, LibreSoC, one could still also go to a schematic like design capture. But that's something that I would really see only as kind of a getting started. You typically grow on your challenges. So doing the start with the CLB synthesizer and then moving to something larger like LibreSoC, and then also working on some larger and also more capable boards is typically something which comes at some point pretty natural. And also to support this going into the FPGAs, what we have from our side, from the FPGA business unit, is also free licenses for LibreSoC, the so-called silver license. This is a license which allows the use of the smallest two devices of each family and also the devices that we have on the board. And in addition to that, also obviously you want to go into hardware. So also low-cost kits are something that are pretty essential. We have two active families that I would still recommend today. The existing one, or the smaller one, is Smart Fusion 2 Igloo 2. That's relatively small from a complexity perspective, somewhere going down to 6,000 logic elements. And on the Smart Fusion 2, having an M3 microcontroller, the simplest board that you can have there is the SMF 2000, done by Trans Electronic. This only sells at about, I think, 50 euros, whatever that currently is converted into dollars. And then on the other side, on the newer architectures, PolarFire FPGA, PolarFire SoC, we have then some other board which we call the Discovery Kit. This is based on PolarFire SoC, a device already having close to 100,000 logic elements and an application class processing core set of 4 processors. And that board is priced at about $130. So that's really getting into the hardware when you have everything already. And obviously the question is also, how do you get familiar with the tools? Probably the easy answer on that one is, well, first of all, really have a look at some of our tutorials that we have both on YouTube and on GitHub, which are showing you how to run the tool, how to run LibreSoC, what to do there. And OIC, I have to admit, yes, it's a tool that needs to be installed, but it's still, for FPGA tools, still relatively slim. I think it's currently about 30 gigabytes, so not really that large in today's market. And with those tutorials, with the YouTube videos, typically it's pretty straightforward to go into the tools. Plus, then also when you have mastered simulation, when you have mastered synthesis, you already have something to put onto your resume, because the tools that we have in the background, QuestaSim for simulation, Simplify Pro for synthesis, are two very well-known industry products, industry tools, and that will definitely help you over your career.
Fantastic. Yeah, definitely recommend that our listeners check out those free tools across those platforms. Well, thank you very much for your insights so far. But before we wrap up, is there anything else that you'd like to add? Any final words for our listeners? Perhaps Martin, I'll start with you.
Yeah, what I can say really on FPGAs is really think about them early. Think about the flexibility that you can get. Think about what is it actually that you really need to tackle, where you need to have the low latency or really the specifics on doing something proprietary for you. That's typically where the FPGAs excel. And those well-known truths that you remember from university, forget about them. And maybe just as Josh already mentioned, one URL, the one URL that you should probably also remember, or actually two URLs that people should remember is, first of all, microchip.com/polarfire, information about the PolarFire FPGAs. And then also for some of the tutorials, github.com/polarfire-SOC. That's where both the software and the hardware tutorials are located.
Excellent. And Josh, what about you? Any final thoughts?
I think Martin did a great job covering what you should consider if an FPGA in your design is for you. My 2 cents would be that if you think you might want one, don't be turned away by the complexity involved. There are a lot of great resources to get started. And as I said, if you want to use the CLB as your entry-level point into the programmable logic space, there's a tutorial online on YouTube that you can do a design in under 5 minutes.
Fantastic. And finally, YC. Oh, sorry, Martin, we'll come back to you.
Maybe just an idea, a thought that came to my mind, more of an image. If you think about traffic or doing some transport, you can have kind of the wheelbarrow, you can have your car, and you can have the 40-ton trucks. If you want to do something in your garden, you're probably not going to come with the 40-ton trucks because it will just mess up everything. So you really need to have the right tool for the right job. And that's where the scalability from the small CLB-based FPGAs up to the mid-sized FPGAs that the FPGA business unit provides are probably a really good fit.
Yeah, good analogy. YC, coming to you.
Well, so I'm going to use an analogy as well. I think the common misconception about FPGAs in general is that they are hard to use, and in general, people do not design with them, and that's completely not true. That is a more advanced device, a more advanced design skill to have, and it complements very well with embedded microcontroller skills. And in addition to that, I view that as designing with an FPGA is like driving a stick shift or manual car, where you get full control over everything, but it is a more advanced skill that you have to build muscle memory, or in this case, domain knowledge to operate. But once you get the hang of it, it is an incredible device type to use in designs.
So many good analogies. Okay, well, thank you very much, YC, Josh, Martin. It's been a pleasure speaking with you, and I know our listeners will appreciate your insights. So thank you very much, and enjoy the rest of your day.
Thank you, Paige. Thank you all.
Thank you, Paige.
Thank you.